Okay, so we're back here. That compiler was giving issues, so I've just changed the compiler to the new one compiler. If you just put this in Google, you should be able to get to this compiler, and it seems to work. So we were here in the last video where we were able to print the parent process first, and then the child process was getting printed. Right, and what we said was that we'll have to use the wait system call, which is this one here, which this system call will wait for the process to change its state. And remember, we need this new library, which is called #include sys/wait.h. So you'll have to include this on the top before you use the wait function. And remember, the wait system call has to be used in the parent side of the process. So in the else, you have to say wait and put null inside the brackets. This is like the parameter, which we will learn later on how to do this in C. But for now, just remember to pass null as the parameter. And if I run this, let's see what happens. So hopefully it runs in this compiler now. So now look at that. Just because we put wait null here, the child process runs first, and then the parent process. So this is the important bit here. If you want the child process to run first, use wait in the parent side of the process. And remember, the wait should not be used in the child part of the process. Because if you use wait here, it will wait for its child, which is just not there because there's only one fork function here. Okay, next bit now. So now we will learn another type of process, which is called the orphan process. In this, what happens is the parent process finishes running. So let me write this down. The parent process finishes its run, but child remains. And then the child is not able to find its parent. Okay, so once again, the orphan process is when the parent process finishes its run, but the child remains, and then the child is not able to find its parent. That's why the name given to this is called the orphan process. Now, in order to make an orphan process, what you can do is you can just comment out the wait here, and you have to use another function in the child part of the process. So this is the child part. Let me just write it here. This is the child part of the process. So in the child part, you use another function which is called sleep. And in the brackets, you give for how many seconds do you want the child to sleep. So while the child is sleeping for 3 seconds, the parent will run. And then when the child wakes up, the child won't be able to find its parent. And that is called the orphan process. So let's see if I run what happens here. So if I click on run, hopefully no errors. So if I run this, look at this, the parent process has run and is able to find its child. But when the child wakes up and runs, it's able to find its process ID. But when it starts looking for its parent, it is just not able to find the parent process ID. It's just saying my parent process ID is 1. So it means the parent has finished processing, left the program, and the child is not able to find its parent. So very important, this is the orphan process. We'll learn one more process, which will be called the zombie process. In this case, the child will finish running or finish its execution and leave the program, but the parent will think it is still in system. Okay, so once again, the zombie process is when the child will finish running and leave the program, but the parent will think that the child is still in the system. So the parent will think child is still in the system. Okay, in order to do that, you have to get rid of sleep from here and put sleep in the parent side of the process. So let's call this the parent side of the process. And here you'll have to say sleep, and let's do 3 seconds again. And run this and see what happens. So if I run this, the parent is sleeping for 3 hours, the child is running. So the child has made its run first and has left the building, but the parent runs again and he thinks the child is in the building or in the program, but the child is not in the system anymore. And how do we check that? Inside the parent side, you can use another if. So we can just repeat this code here, saying that if the function ID is 0, let's see. So inside the parent side of the process, you can repeat the if and say if the function ID is 0, it means if the child process exists, then print let's see, we can say child is here, right? So if the function ID of 0 has been found, it will say the child is here, or else it will say child not here. Right, let's see. Okay, should there be an if close here? Yeah, let's close an if here. Okay, so what this bit will do here is, after the parent has given the child ID, thinking that the child is in the system, the program will look for the function ID with 0. It means it will check if the child is there. If it is there, it will say the child is here. If not, it will say the child is not here, even though the parent thinks that the child is there. So let's see what happens if I run this. Let it go. Okay, fingers crossed, no errors. Let's try and run this. So the end here, we should see an output saying either the child is here or not here. So let's see if I run this process. Child is not here. Look at this. So even when the parent thinks that my child ID is this guy, but the child is actually not there. So this is called the zombie process, in which the child has left the program, but the father or the parent still thinks that it is in the system. Okay, so let's just recap. We learned if else with fork first, which was in the previous video or at the beginning of the video, which gave an error in another compiler. So we changed the compiler to this. Then we saw how to run the child process first using the wait system call, which is this bit here. Then we learned how to make an orphan process, and then we learned how to make a zombie process. Look at these videos and then try to do the practice on Blackboard. Any questions, type in below. I'll stop the recording.